Even though we can make some very amazing looking visual effects with Unity's particle system, the actual particle system component is very simple. In this section, we're going to look at the particle system, and we're going to look at the different modules that are used to make every particle system look unique. And we're going to look at the modules we use to build cool looking visual effects. The first thing we should do when examining a particle system is to actually create one in our scene. I'm going to go ahead and create a particle system by going over to my hierarchy window and selecting Create, Particle System. I'll see a particle system gets added to the scene. One thing that's worth noting right off the bat is with this particle system, the z-axis is pointing upwards. Since particle systems always emit their particles along the z-axis, they are automatically created with a rotation about the x-axis, so the particles shoot up instead of forward. Keep this in mind as you work with particles and try to position them in the scene. If I look in the inspector, I'm going to notice the particle system component has a lot of pieces to it. These pieces are called modules, and they control how the particle system looks and behaves. Furthermore, we have something called a particle effect window in our scene view. These particle effect controls can be used to stop, pause, or re-simulate a particle effect in the scene view. You'll also notice that the particle system is playing even though my scene is not playing. We can modify, test, and see our particle effects without ever having to run our scene. This is very useful as this allows us to quickly and easily tweak our modules in the inspector and see the effects right away. As you can see on the controls in the scene view, the title is Particle Effect. However, if I look at the component or the game object that was created, it says Particle System. There is a difference between a particle system and a particle effect. A particle system is simply one instance of a particle emitter, say something like smoke. If you were to stack several particle systems together though, you would create something called a particle effect. Say smoke and fire and sparks together creates the particle effect of say a campfire or something burning. So just know every time you see the term particle effect, we're talking about a group of particle systems that achieve one coherent visual effect. Now let's take a closer look at these modules. Every particle system has an emitter and has particles. This particle system module, the first module, deals with properties of the emitter. Now while looking at these modules, it's worth noting that there are a lot of options and we're not going to cover every single one of them here. The fact of the matter is, we're really just going to talk about the ones that are important to us. So some of the ones that aren't used right now, we're just going to sort of skip and we'll talk about them later when they become important. So let's just highlight the important parts of these modules. In the particle system module, the first important one is duration. How long will this particle system emit? Then we have looping, which is whether or not the particle system will continue to emit particles in loop and start emitting again. We have the start lifetime, which is how long in seconds our particles live. In this case, they live 5 seconds. We have the start speed, which is how fast they travel, and we have start size, which is how big these particles are. Now it's worth noting that all of these properties have a numerical value. However, I can click the drop down next to them and choose a curve instead of a constant. I can also choose a random between two constants or even a random between two curves. So I have a lot of options to vary or randomize these different properties. We have start color, which allows us to determine what color we want our particles to be. And for our colors, we can actually choose gradients, or random between two colors or random between two gradients. So if I were to select a gradient and then click in it, I could get this gradient editor where I could say start white, but then slowly transition to red. And then we could see as the emitter aged over 5 seconds, the color would go from white to red. Our gravity modifier determines whether or not these particles use gravity. And then we have play on awake, which is a very important one, which says when this game object starts up, does it immediately start emitting particles, or does it only emit particles when we tell it to? The emission module is also really important. It's going to determine how many particles we spawn at a time. So we could say that we want our particle system to have a rate of 50. Doing so would greatly increase the number of particles. We could also say that we wanted a rate of something like 0. Doing this would cause no particles to be emitted. However, the next section is our bursts. Bursts are basically groups of particles emitted at certain times. So we could add a burst of, say, 30 particles right at 0 seconds. We could add another one at, say, 3 seconds that burst another 30 particles. Removing these bursts is also very easy. We just hit the minus sign right next to those. Now we don't necessarily have to emit by rate. We could also emit by distance. So if we were to say something like, change our rate to something like 50, and then change our simulation space from a local coordinate space to a world space, we could see that as we moved our particle system, particles were emitted. This is great for things like maybe a car that has exhaust or a flaming arrow that leaves a trail of sparks behind it. I'm going to go ahead and set those back for now. And we'll go back to time with a value of 30 so that we're just back to the way we were. The next module that's important is the shape module. The shape module obviously determines the shape or geometry of the emitter. This is also a very important one. By default, it's set to a cone, but we have a lot of options. We could do something like a sphere, so it emits in a 360-degree radius. We could do a hemisphere or a half circle, a box, mesh, a mesh renderer for a custom mesh, skinned mesh renderer to say maybe make a character object, maybe make a character model that appeared on fire, a circle, or even an edge if we want to do something like rain effects. Now, apart from changing the shape, we can also change angles and the radius to change our effect. We have the ability to say that we want it to emit from the base of our geometry or from the shell of our geometry, so they only emit from the outside. You'll see that none are emitting from the inside of that base. We could do the volume, which means particles can emit from anywhere inside the volume, or volume shell, meaning they can only emit from the outside of the total volume. We even have the option to say random direction, which causes the particles to go pretty crazy. I'm just going to go ahead and set these back so that we can continue on. Now, besides the base particle system module, the emission module, and the shape module, the rest of these are all fairly formulaic. They're all kind of similar. They just modify different parts. Also, unlike the particle system module, the emission module, and the shape module, the rest of these modules deal specifically with the particle. Now we're describing things about the particle, not the emitter. That's an important distinction. When we're talking about color in these modules, we're talking about the color of the particle itself over its lifetime, not the emitter lifetime. We'll see this start color starts white and goes to red over the life of the emitter, but this color over lifetime is over the lifetime of each individual particle, causing the particle to change color. That might seem confusing, but once you grow to understand it, you're going to notice that it's quite intuitive and it's actually pretty simple to work with. So let's just go through the rest of the modules pretty quickly. We have our velocity over lifetime, which is going to add velocity to each individual particle over its lifetime. To enable any module, we simply have to click in the upper left-hand corner of it. So we can apply some velocity, and we can also specify whether we want local or world space. We have the option to do constants, curves, random between constants, or random between curves. The next module is our limit velocity over lifetime. This basically says that if our particles start traveling too fast, slow them down. We can either say if their total speed is a certain amount, slow it down, or we can separate out the axes so we get to choose how fast along each axis. Dampen allows us to specify what we want it to do once it starts going too fast. Inherent velocity means that the particles themselves will inherit the velocity of the emitter. So if the emitter was on, say, an airplane traveling very quickly, those particles would emit, inheriting some of that velocity. The next module is force over lifetime, which will apply a force to a particle over its lifetime. And again, we can do constants, curves, or randoms. Then we have color over lifetime, which allows us to change the color of a particle over its individual lifetime. To show this as an example, we'll look at the particles in the scene view and we'll see that they are all white and then some of them look pink, and then some of them look red. If you watch any one particle, you'll see that the particle itself never changes color. The color it's emitted as is the color it stays. I'm going to go ahead and change this back to a single color, white. And down here, I'm going to change it so that we have a gradient. And we'll go from white to red. And now what we'll see is each particle changes color over its own lifetime. That's really the difference between setting properties on the emitter versus setting properties for the particles themselves. Next, we have the color by speed, which allows us to determine the color based on the speed of the particles. We could say as the particle goes faster, it changes color to say from white to red, or vice versa. Size over lifetime allows us to determine whether or not our particles will grow as they age. So I could, for instance, say that they start very small and they get bigger as they age. And if we zoom out, we'll see that they go from small to big. Size by speed is just like color by speed. We can set a size based on how fast the particle is traveling. Rotation over lifetime allows us to apply some rotation to these particles. This isn't super useful right now because we're dealing with basically a 2D billboard. We won't actually be able to see any rotation. But when we're doing things with custom textures and custom materials, like say billows of smoke, rotation will be very apparent and very necessary. Rotation by speed simply applies rotation based on how fast a particle is going. The external forces module determines whether or not external forces are applied to these particles. Those external forces can be things like wind zone. If we uncheck this, then things like wind will not affect our particles. Collision allows us to determine whether or not these particles collide with the world. Now, collision is very heavy for particles. It's very inefficient. So just be aware that you really only want to use collision if you really need it. That being said, there are two types of collision. The first is planes collision, where we can determine simple flat planes that our particles can collide with, or world collision, where our particles are actually able to collide with the world. Obviously, world collision is the most inefficient type of collision, as our particles have to be checked against all game objects they could possibly collide with. Again, it's really only worth adding particle collision if we really need it for some specific effect. The next module is my personal favorite, the subemitters module. The subemitter module allows us to create additional particle emitters based on some event in the particle's life. For instance, we could create additional particle emitters on the birth of every particle, or on the collision of a particle, or on the death of a particle. Let's say I wanted to emit more particles whenever a particle died. I could simply come down to the death particle system and hit the plus icon. Now what I'll see is when my particles die, they explode into subparticles. This has also created a subemitter underneath my particle system in the hierarchy. To make these more visible, we can simply change their color. For now, I'm going to go ahead and remove this. And we can delete this subemitter from our scene. After the subemitters module is the texture sheet animation module, which allows us to apply texture sheet animations to our particles so that they don't always look the same. They can actually animate through several frames. We'll get a chance to work with some of these texture sheet animation particles in a later section. Finally, in order for our particles to be drawn, we have to have the renderer module, which is on by default. The renderer module is where we can change our render modes, our materials, some of our sorting options, whether or not we want shadows, and our sorting layers. Basically, everything that has to do with rendering our particles is handled here in the renderer module. This seems like a lot to remember, as there are a lot of modules with a lot of separate properties. However, we're going to use this system pretty exhaustively in this chapter. We're going to build several particle effects, and we're going to see how we can use all of these modules together to build really unique looking attacks for the player. Therefore, you really shouldn't worry about it at this point. We're going to get to see all of the different features of this particle system, we're going to see them in action, and by the time we're done, you're going to be an expert on using this particle system component.